Okay, so welcome to this video. We are going to revise questions from Chemistry Test 2 and Quiz 2. So it turns out that most of the questions from Quiz 2, okay, this is the Quiz 2 paper here. So most of the questions that you can see here, Quiz 2 had 15 multiple choice questions. They are also there in the multiple questions part for test 2. Okay, so I'm going to be revising these papers together. So I'll be telling you that, okay, this question is both in test 2 and quiz 2, and then we revise it. And then also those that we are not in quiz 2, but they're in test 2, we're also going to to revise them. Okay, so that's what we're going to do in this video. Okay, so we start from question 1, which says, which of the following statements about the quantum mechanical model of the atom is incorrect? Okay, so option A, they're saying the position and momentum of an electron cannot both be known at the same exact time. Okay, so this one is true because that's just the Heisenberg uncertainty principle. Okay, so that is true. And then when you go to option C, I'll skip option B for now. If I go to option C, they're saying atomic orbitals are regions of space with a high probability of finding an electron. Okay, that is true because that's just the definition of what? An atomic orbital. And then D, they're saying the energy of an electron is quantized and describe the quantum numbers. Okay, this is also true here. No wonder we find the principal quantum number, and then we find the angular momentum quantum number, the magnetic number, okay, and then the spin quantum number. Okay, so the spin quantum number has to be, this one is the spin, right? Okay, so this magnetic quantum number is ML, and then the spin quantum number is MS. Okay, so the energy of an electron is quantized, okay, meaning that it will be described, okay, by the four quantum numbers that we have. All right, so the only wrong option here, or the incorrect option, is this one where they're saying electrons occupy fixed orbits at fixed distances from the nucleus. Okay, so this one here is not correct according to the quantum mechanical model. Okay, so in the quantum mechanical model, the electrons do not move, okay, in fixed circular orbits. Okay, they do not move in fixed circular orbits. Instead, they exist in orbitals, which are just regions of space with a high probability of finding an electron. So the incorrect option here is option B. Okay, so that would have been the answer here. And this question 1, okay, this one is from quiz 2. It's the same as question 1 from test 2. Okay, we'll move. Question 2, they're saying which of the following number of electrons, they're saying what is the maximum number of electrons, okay, that can have the quantum numbers n is equals to 3 and L is equals to what? To n. Okay, so how do we solve that? Okay, first of all here, you have to know that when L is equals to 0, then we are talking about the S subshell. Okay, so the S subshell has one orbital. Okay, it has one orbital, meaning that the maximum number of electrons that it can have will be what? Okay, will be 2 electrons. Okay, because each orbital can only hold a maximum of 2 electrons. So the S subshell, when the L is 1, or the magnetic quantum number, I mean the angular momentum quantum number, okay, when the angular momentum quantum number is equals to 0, this L here indicates the angular momentum quantum number. It means you have the S subshell, okay? When this guy is 1, then you have the P subshell. So the P subshell has 3 orbitals, okay? And each of these orbitals will contain 2 electrons. So meaning the maximum there will just be what? 6 electrons. Okay, when L is 2, we have the D subshell, which has 5 orbitals. Okay, so this one, since each of these orbitals will contain 2 electrons, the total number of electrons that can hold is 10. Then when the L is 3, we have what we call as the F subshell, which is 7 orbitals. Okay, it has 7 orbitals, meaning the total number of electrons will just be 14 what? Electrons. So in case they ask you the others there, no wonder I was writing them down. So here my L is what? 1. Okay, so my L is 1, so I'll just go there. What are the total number of electrons that I can see? 6. So I pick 6 as my best answer. Okay, so meaning that if your L was 0, you would pick 2. If your L was 2, you'd pick 10 there. If your L was 3, you'd pick what? 14. Okay, and this question here is the same as question 2 from test 2. Okay, let's look at question 3. Question 3, they're saying which of the following electron configurations is not allowed based on the Pauli exclusion principle. So the Pauli exclusion principle simply states that no electron can have the same set of the 4 quantum numbers that we have. Okay, no electron or no one electron can have the same set of the 4 quantum numbers that we have. Okay, so when we look at the electron configuration here on A, that one there is just a normal electron configuration. There's nothing wrong with it. Okay, because we said for the S subshell, the total number of electrons were 2 from the previous question, right? For the P, the total number of electrons, they were 6. And then for the D, the total number of electrons were what? Were 10 electrons. Okay, so this S can be filled with 2 electrons at maximum or less than that. And then the P, 6 electrons at maximum or less than that. And then the D, 10 electrons at maximum or less than that. Okay, so when I look at this first electronic configuration, I have 1s with 2 electrons, that's fine. 2s with 2 electrons, that's fine. 2p with 6 electrons, that's also fine. Okay, when I look at B there, it's also correct. Why? Because in the SSS, I can see 2 electrons or less than 2. For example, this one has less than 2. And then in the D, I can see 10. Okay, nothing wrong with that. And then the P, I can see 6. Even there, the P, I can see 6. So nothing wrong with that. So this one is correct. Even this one is correct. Okay, but we'll look at C. C is S, 1s2, 2s2, 2p, 6, and then again I have a 2p. So when you're writing these configurations, the 2p can only come once. Okay, it can't come twice. So this one here is definitely wrong. Okay, but here the electrons are just fine. There they're just fine. There they're just fine. But this 2p repeats itself. So this is wrong. Okay, once the subshell the subshell has been assigned, it can't repeat itself. Okay, so the wrong one here would be option C. Okay, option C is wrong. And then this one here, based on what I've explained, you can also try to check it out. You see that it's correct as well. So this question 3 was the same as question 3 from test 2. Okay, so now we look at question 4. Question 4, they're saying, what is the effective nuclear charge, okay, experienced by a 3p electron in a phosphorus atom that has the atomic number 15? Okay, so to find the effective nuclear charge, we just use the formula, okay, atomic number minus the shielding effect. Okay, so this S here means the shielding effect. In some books, they write sigma like this. Not okay, so this is not 6, but it's a symbol called sigma. Okay, but for simplicity, let's just use S, meaning the shielding effect of those electrons that we are talking about. So here they're saying, what is the effective nuclear charge experienced by a 3p electron? Okay, so before we even do that, we need to know the rules. Okay, so if, for example, an electron is in a certain energy level, okay, let's say N, okay, so this N will have a lot of electrons, right? And then we're just focusing on the shielding effect that of one of those electrons in that energy level. Okay, so if the electron of interest, okay, is in this energy level N, and then there are also other electrons in that energy level. All those other electrons in that same energy level as the electron of interest, okay, are going to be contributing 0.35 to the shielding effect. Okay, so for example, if in this N subshell, I have maybe 5 electrons, right? And then my electron of interest is one of these electrons. Okay, so my electron of interest is one of these 5. So I have one electron of interest, and then I have 4 other electrons, right? Okay, so these 4 other electrons are each of them are going to be contributing 0.35 to the what? To the shielding effect. So to find the total shielding effect, okay, of these 4 electrons, for this one electron of interest, we are going to say 4 multiplied by what? 0.35. Okay, that's how we are going to be finding the shielding effect, that the electrons in the same energy level as the electron of interest are what? Contributing. Okay, what about those in a lower energy level, let's say energy L minus 1. Okay, so those in a lower energy level, okay, N minus 1 are going to be contributing, okay, are going to be contributing 0.85. Okay, and then those even in lower energy levels, okay, so meaning N minus 2, N minus 3, and so on. These ones are going to be contributing 1 to the what? Uh, to the shielding effect. Okay, so now here we've been given phosphorus atom. Okay, so the first thing that we have to do is write its what? Electronic configuration. Okay, so its electronic configuration is written as 1s2. Okay, I taught how to write these electronic configurations in the Tutor sheet. So check out the Tutor sheet. So it's 1s2, 2s2, okay, 2p6, and then 3s2, and then 3p3. So this is the electric configuration of the what? Of the phosphorus atom. So here we are trying to find the effective nuclear charge for a 3p electrons. So one of these electrons that are in the 3p here, okay, that's the effective nuclear charge that we are calculating. Okay, so to find the shielding effect here, I'm going to follow these rules. Okay, so for the electrons that are in the same energy level, so the energy level is the number in front there. So those that are in the energy level number 3, okay, apart from the electron of interest, which is one of these 3 here, how many electrons do I have? I have 2 there, and then I also have 2 there. Okay, so I have 4. So those ones in the same energy level as the electron of interest, we said they're going to be contributing what? 0.35. Okay, so when I multiply that, I get 1.4. And then those that are in a lower energy level, these ones here that are in 2, 2 there, they are 2, 8. So those in N2 are going to be, I'm writing in N8 now. So those in N2 are going to be 8 multiplied by them, they contribute 0.85 to the shielding effect. So if you multiply that on your calculator, you find 6.8. Okay, and then those that are in even lower energy levels, okay, so for example, this one here, which is in 1 there. Okay, so that one in N1 is going to contribute 1. So how many electrons do I have there? I have 2 multiplied by 1. It's just going to be equals to 2. So now I'll add all these here. That's how I'm going to find this, my S there, which is just the shielding effect. Okay, so if I add all those, my S, I'm finding it as 10.2. Okay, so that is my shielding effect. All right, so now I can find my effective nuclear charge. Okay, will just be equals to the Z, which is 15 minus 10.2 is equals to, okay, so I get 4.8. So when you notice on the options, you don't have the 4.8. Okay, so you get the one which is very closer to the 4.8. No wonder here the C was the answer. Okay, so another way, but the other way won't give you the accurate answer. It will just give you an approximate answer. Okay, the other way is that you can find the effective nuclear charge, okay, by saying Z, which is 15, minus the number of electrons, okay, the number of electrons apart from the electron of interest. So remember my electronic configuration was something like this. That should be 2. Okay, 2, and then 2p6, 3s2, and then 3p3. Okay, so I was saying you subtract the nuclear charge minus the number of electrons that are not of interest. So our electron of interest will just be one of these. Okay, so if I can add 2 plus 2, 4 plus 6, 10. Okay, oh, what did I say? Okay, so the other way in which you can find an approximate, I didn't say it correctly, is you say the nuclear charge, which is 15, minus the electrons that are not in the energy level where the electron of interest is. Okay, so the electron of interest is in the 3. So meaning all these ones here in 3, 3, 3, 3 here. Okay, you avoid them. So we're just going to add these ones here. The ones that are in the energy level, okay, which is not of interest, okay, or the energy level that contains the electrons that are not of interest. So this one was in the 3p. So meaning the energy level of interest there is 3, right? So we avoid the electrons in the 3n, and then we just add the ones that are lower. So this is going to give you 10, and then you subtract, going to give you 5. But this will not give you the exact answer. To just give you an approximate. That is, if you are in a hurry, maybe you have no time to do this, you can also use this, but it just give you an approximate. Okay. All right. So there, the answer is C on 4. And then here, okay, we can do the approximate way, and this also we can do this. Okay. So the approximate way will just be the effective nuclear charge Z is 16 minus the electrons, okay, that are in the energy level where the electron of interest does not belong. So the electronic configuration for this guy is 1s2, 2s2, okay, 2p6, and then 3s2, and then 3p4. Okay, so the electron of interest is in the 3p. So I avoid counting the electrons in the what? In the n3. I just count these. So this is 10, then minus to give me 6. So I have the answer there, 6. But if you want, we do this again. Okay, we're going to find 5.45 if we do this method here. So which one is closer to the 5.45? It's the 6. Okay, so you use this if you do not have time. Okay, but in the exam, make sure you show this, especially if it's in section B or section C where I'm showing the work. Make sure you show this one. But for the multiple choice, we can actually get away by just using this trick that I said there. Okay, but remember the rules that I said there. And then also, you can read more on these rules, okay, of this part that I've included here at the corner. Okay, you can read more here. So you can just screenshot, read through, try to understand, so that any question that comes in that area, you're able to what? To answer. Okay, so I'll move to question 5 now. So I forgot to mention here, in quiz 2, we had this question. Okay, you see here the Z was just 15. In test 2, we had this one, the Z was 16. Okay, so similar questions. And then here now, they're saying the ionization energy increases across a period due to, okay, so I explained this to length when we're doing the Tutor sheet. It increases because of the increase in the effective nuclear charge. So no wonder it's the answer there. Then here the electron affinity decreases across a period due to, okay, so here you can see across a period, across a period. So whatever the ionization energy does across a period, the electron affinity is going to do the opposite, but the reason for doing that will be the same. So the ionization energy increases across the period, right? Due to the increase in nuclear charge. So the electron affinity is going to do the opposite of what the ionization energy does. Meaning if the ionization energy increases, it is going to decrease, but the reason for decreasing is going to be the same. So it's decreasing because of the increase in the nuclear charge. So the answer there is also C. So this question was in quiz 2. This one was in test 2. Okay, so if you want more videos on the electron affinity and ionization energy, we did that in the tutor sheet. That was tutor sheet 7. I explained to length. You can check out those videos on the website or on our mobile app. Okay, so our website is just discrete learning.com. Okay, and then we go to question 6. They're saying, which principle explains why electrons fill the lowest energy level orbitals first? Okay, so that principle is known as Aufbau principle. Okay, so it states that electrons must fill first the lowest uh, energy orbitals available before filling those that have what? Higher energy. Okay, and then the hand rule, okay, the hand rule simply explains that, okay, um, simply explains that electrons must first fill the orbitals, okay, singly before pairing up. So meaning that if I have maybe one S2 and then I have I have two S2 and then I have two P and then let's say 4. Okay, so when filling this orbital, when filling the orbitals in the P subshell, okay, remember the P, okay, has 3 orbitals like this. So this is a 2p. So it has 4 electrons, right? So we first fill them singly like this, okay, before you start pairing them up like this. Okay, so some of you are going to do, you put there and then you put there and then you put there and then you put there. So this one here, according to hand rule, is wrong. Okay, you first have to fill them singly like that, like that, like that, and then you start pairing them up like this. Okay, so that's what hand rule states. And then the Pauli exclusion principle, I've already explained it. It just states that no one electron can have the same set of the 4 quantum numbers. Okay, it can have the same 3 set of the quantum numbers, but when you come to the magnetic spin number, it's going to differ. Okay, it's going to differ because one of the electrons is going to face up, so it will have a plus 1/2. The one is going to face down, so it will have minus 1/2. And then this Heisenberg uncertainty principle, okay, is what we did on question 1. Okay, so simply saying you cannot know uh, the position. Okay, you cannot know uh, okay. So I was saying the Heisenberg uncertainty principle simply states that the position and the momentum of an electron cannot be known, okay, exactly at the same time. You either know the position, okay, then you don't know the momentum, or you know the momentum and you don't know the position. Okay, so you can't know them at the same time. All right, so here the answer to this statement here was C, and I've explained what hand rule is, what Pauline exclusion principle is, and what this uncertainty principle is. Okay, so this one here was question 6 from test 2, which just state which principle explains why electrons fill the orbitals singly before pairing up. I already said this is hand rule. Okay, so this was in test 2, this was in quiz 2. We've covered them both here. Okay, go to question 7. They're saying if K is equals to 0.040 for the system below at 450 degrees Celsius, calculate Kp. Okay, so Kp is the equilibrium constant in terms of the what? In terms of the pressure. Okay, and then Kc is the equilibrium constant in terms of the concentrations. Okay, so Kp is related to the Kc by this formula. RT and then change in N. Okay, so Kp will just be equals to this one here, the Kc is the same as the K, so I write it there. Okay, and then the R is the gas constant, which is 0.0821, okay, multiplied by the temperature. So that temperature, you have to change it to kelvins. Okay, so if I do 450 plus 273, okay, I get 723. And then the change in N is just simply, okay, the number of molecules on the product side minus the number of molecules on the reactant side. Okay, so on the product side here, I can see 2 of them. Okay, so that would be 1 plus 1. So I get 2 minus, and then on the reactant side, I can only see 1. So that is 1. Okay, so you punch this on your calculator. I'm getting 2.38 approximately. So you round this off to 2.4. Okay, so that will be our Kp value. So we choose the C there. So this was question 7 from quiz 2. And then question 7 from test 2 was this guy here. So here they're saying, okay, K is equals to 4 times 10 to the power minus 2 for the system at 225 degrees Celsius. And then they've given us this equation, okay? Evaluate K for the reverse reaction at the same temperature. So for the forward reaction is when you're moving from this side going to that side. So the K for the forward reaction, okay, we can even write it as K forward has been given as 4 multiplied by 10 to the power minus 2. And then now they want us to find the K for the reverse, meaning starting from here, going this side. Okay, so when you want to find the K for the reverse, okay, when you want to find the K for the reverse, you just say 1 divided by the K for the forward. So this will be 1 divided by 4 multiplied by 10 to the power minus 2. If I punch on my calculator there, what do I get? Okay, I get 1 divided by, okay, I get 25. So the K for the reverse is 25. So I'll come and select option B there. Okay. So this was the question 7 for test 2. I go to question 8. Okay. So both quiz 2 and test 2 had the same question on question 8. Okay. So which of the following is not a type of electromagnetic radiation? Okay. So X-rays, this is electromagnetic, microwaves, electromagnetic, radio wave, electromagnetic. So sound here is what we call as a mechanical wave. Okay, it's a mechanical wave. So it's not an electromagnetic wave radiation. So what does it mean to be electromagnetic? Okay, it means those radiation, they travel through a vacuum. Okay, they don't need a medium to travel. They travel through a vacuum. Okay, so X-rays, microwaves, radio waves, they travel through a vacuum. But the sound wave is a mechanical wave because it needs a medium to travel. Okay, it needs a medium. For example, like air, okay, it needs water or it needs some solid of stuff. So like when you hit on the table, like boom, for you to hear that sound, okay, you need this medium, the solid. If there's no solid, you can't hear the sound. Okay, the air, for example, thunderstorms, it's just the movement of air. Okay, hot air has moved and it has left a gap, and then cold air comes and fill in that gap. Then you hear guru. Yeah, so you need air, okay, for that sound to be heard, the thunderstorm. Okay, and then for the water again, if you just get maybe something and then you hit on water, it will make a sound, right? Okay, so water is a medium. So for you to have sound or sound waves, you need a medium. Without a medium, there will be no sound waves. So sound waves are what we call as mechanical waves, simply meaning they need a medium. Okay, so the answer there, we're going to pick C. All right, and then we move to question 9. They're saying the wavelength and the frequency are related by. So both quiz 2 and test 2 question 9 was the same. So we know that the speed of light is the wavelength multiplied by the frequency. So this symbol here is for the frequency. Okay, so which one of the equations there are like this one? It's just this one on A. Okay, we move. Question 10 again, quiz 2 and test 2 on question 10, they are the same questions. So they're saying if light has this wavelength, okay, its frequency is approximately. So we know that the speed of light is 3.0 times 10 to the power 8 meters per second. And then here I've been given the wavelength, lambda, in terms of nanometers. Okay, so I know nano is the same as 10 to the power minus 9. Then this will be in meters now. So I've just replaced this nano with this. So you go back to the first topic when we're doing units. Okay. All right. So now I need to find the frequency. So the formula is speed of light is equals to wavelength multiplied by the frequency. So the frequency will just be speed of light divided by wavelength. So this will be 3.0 times 10 to the power minus, to the power 8, divided by 650 times 10 to the power minus 9. So this one gives me a wavelength of about 4.6 times 10 to the power 14 Hertz. Okay, or second to the power minus 1, or per second. Okay, so I just go on the option that has that one. I select it as my answer. Okay, let's look at question 11 now. Question 11, they're saying the conventional equilibrium constant expression Kc for the system below is. So what you have to know here is that the equilibrium constant expression only includes um, species that are either in aqueous form or they are gases. Okay, so meaning that if you are a solid or you are a liquid, you are not going to be there in the expression. So here, okay, remember the K expression is the products over the reactants. So now here, I can see that the reactant is solid. So I can't put it in my K expression. Okay, and then also this product is solid, so I can't put it. So the only thing that I have is this guy. So I'll say the concentration of Cl2. And then for the reactants, we don't have anything there in gas or in aqueous, so just divide by 1. So this will just be the concentration of CO2. So no wonder here is the answer, so we select it. Okay, and then here, question 11 from test 2, they're saying the conventional expression, the conventional equilibrium constant, okay, expression Kc for the system below in reverse is, okay, so this one that we found was the forward one. So to find the reverse one, we just say 1 over the forward one. Okay, so we choose whatever option we have this. So that will be D there. So we select D. So we see that these are almost similar questions, but this one came in test 2, this one on quiz 2. Okay, question 12, they're saying the energy of a photon is given by, this one I don't have to even explain, that's the formula there. And then this was in quiz 2, this one was in test 2. So in test 2, they're saying the formula for the mass energy equivalence derived by Albert Einstein is by, okay, so the formula is just energy is equals to mc squared. So wherever we see this, that's the answer. So I pick A there. Okay, and then question 13, it was the same, both from quiz 2 and test 2. So they're saying here a photon has this energy. Okay, its frequency is, so we use this formula here. Okay, so it will be energy is equals to h multiplied by the frequency. So the frequency is equals to energy over h. So we know h is just Planck's constant, right? So the energy is 7.5 times 10 to the power minus 16 joules over the Planck's constant. Okay, the Planck's constant, we know it has a fixed value, which is 6.626 multiplied by 10 to the power minus 34. So we divide this on the calculator. Okay, so if I divide that, it's going to give me approximately. Okay, approximately, it's giving me 1.13 times 10 to the power 18 Hertz. So we choose the answer which is very close to this, which is option what? A. Okay. Question 13. Now this is 14, I mean. They're saying for the reaction, okay, carbon monoxide plus chlorine, okay, gives this product. If pressure is increased, equilibrium shifts, okay? So here, if the pressure is increased, okay, then this is going to favor the side with the fewer molecules, okay, with the fewer molecules or the fewer moles. If pressure is decreased, the equilibrium is going to favor the side with more, okay, with more moles or more molecules, okay? So here I have this equation here. So on my reactant sides, okay, how many molecules do I have, or how many moles do I have? I have 1 here and 2, so I have 2 on the reactant side. The product side, I have 1, okay? So we said if the pressure is increased, it favors the side with the fewer moles, okay? So it means that the equilibrium will shift to the right, where we have the fewer moles, because we have fewer products there, and the products are on the right. So if pressure is increased, okay, the equilibrium shifts to that side which has fewer moles, which is just on the right side here. So no wonder we pick A there as the best answer. So this was the question that was in quiz 2. And then in test 2, they are saying for the reaction, this one here, if the pressure is decreased, the equilibrium shifts to, we say the equilibrium shifts to the side with more moles, okay, or more molecules if the pressure is what? Decreased. So here we have 2 molecules. If I add this and this, then even here we have 2 because there's a 2 in front there, okay? So if the number of molecules are equal, okay, if the number of molecules are equal, like in this case, the equilibrium is not going to shift anywhere. It will remain the way it is. Either you decrease the temperature, you increase the temperature, it's not going to move. Okay, so here we're going to say there will be no change. Okay, why? Because the number of molecules on the left-hand side and the right side are the same. So you decrease the pressure, increase the pressure, no effect. Right, let's look at question 15. So question 15 was the same in both quiz 2 and test 2. So question 15, they're saying which of the following statements is false according to Le Chatelier's what? Principle. So they're saying adding product shifts equilibrium to the left. This is true because if I have A plus B, okay, giving me D, if I add more of this, the equilibrium will shift there. That's true. Okay. Decreasing temperature for an exothermic reaction increases K. Yes, that is true again. And then increasing pressure favors fewer gas moles. This is just what I'm explaining here. You increase, fewer gas moles are favored. So this is correct, this is correct, this is correct. So the one which is false is what? On C. So we pick C there as the best answer for this question. Okay. So at this point where we've reached, it means we have answered all the questions from quiz 2. Okay, and then starting from the other question that I'm going to be doing now, those are exclusively in test 2. Okay, those are exclusively in what? In test 2. Okay, so thank you so much for watching this video. If you'd like to access the full video solutions, okay, where I'll be solving the rest of the questions of test 2, meaning question 16 all the way up to 30, as well as section B, you are free to register with us. You can check the link in the description below. Okay, it's going to give you a link to our website, which is discretelearning.com, a link to our mobile app, okay, as well as a link to a video registration guide. So as you are revising for your exam, for your tests, you can find more helpful videos on our website. Okay, so let me show you the website. So when you go on the website, you'll find something like this. Okay, so we have a lot of courses that we offer here. So if you know anyone who is doing some of these courses, you are free to refer them to us. Okay, so all those who are doing biochemistry, anatomy, human physiology, immunology, and any other medical course that you know, okay, you can refer them to us, or those who are doing math courses. Okay, so here I want to show you what we have in this course called chemistry. So I'll open it. And then I'll go to general chemistry if you are semester 1 Apex or any other university. If you are semester 2 Apex, you go here. So semester 1, okay, you see that we have some folders there that have helpful information for you. So we have lessons and tutorials. So on each topic that you can think of in chemistry, we've solved and we've taught. Okay, on each and every topic that you want, you'll find the lessons there. Here, there are handwritten summarized notes. You can use them, okay, for your advantage. Very well summarized. Here, there are tutorial sheets and assignments. Okay, so all the tutorial sheets for this semester have been solved, and you can find them there. Okay, and as well for the past intakes. The past papers, you're going to find them there. So you can open it, and then you go to the part of the university that you belong. So Apex, you go to Apex. You're going to find video solutions here and as well as written solutions there. Okay, so you see that there are a lot of papers here. We have some exam papers, 2023 January, 2023 July, final exam. We have the quizzes, okay, we have the tests, 2024 July final exam. We have all these papers that can help you prepare for the exam. Okay, so if you like to join our ever-growing community, okay, you are very much welcome. Just check the link in the description below. It will help you register. Okay, so thank you so much. Until next time.